Welcome to the Explainer. Today we're digging into a question that has huge consequences for our roads, even if you've never thought about it. It's what I'm calling the pavement puzzle. Can a super thin layer of sand really be the unsung hero that stops a flood right under our feet?
You know, this is a challenge that engineers and builders wrestle with every single day when they're putting in the roads and sidewalks we all depend on. And really, it all boils down to one crucial question.
So here it is, the big mystery. Picture this. You've got a road, and underneath it is this dense, stubborn clay that water just, well, it can't get through. The plan is to add a tiny 40-millimeter layer of sand. So, is that little bit of sand a drainage superhero? Or is it just an overhyped myth?
Okay, so to crack this puzzle, we first have to wrap our heads around the single most important scientific idea at play here. It's all about the secret science of how things flow. And that big idea is called permeability. Now, you might hear engineers call it hydraulic conductivity, but don't let the fancy name fool you. It's just a way of asking how easily can water pass through something. If it has high permeability, water zips right through. But if it has low permeability, that water gets stuck, and that can create a soggy structural nightmare.
Here's a really easy way to picture it. Think of that granitic sand like a sieve or a colander in your kitchen. You pour water in, and whoosh, it rushes right out the bottom. Now think of the clay subgrade like a sheet of plastic wrap. Water just hits it and stops dead. That is the fundamental difference we're talking about here. All right, now that we've got that idea locked in, let's throw our two materials into the ring for a proper showdown. It's time to check out the hard data and see how they really stack up against each other.
So, in this corner, we've got our challenger, the compacted granitic sand layer. And in the other corner, the foundation it's all built on, the natural clay subgrade. Let's see what the numbers have to say.
And whoa, these numbers tell the whole story. Now don't worry about the scientific notation, just look at those little numbers up top, the exponents. For sand, we're talking -4, maybe -5. But for clay, it plummets all the way down to -9 or even -11. And the bigger that negative number gets, the harder it is for water to get through. The gap between these two is just colossal.
So here's the thing. Those numbers aren't just a little bit different. They tell a dramatic, almost unbelievable story. Let's really break down just how astonishing this difference is.
The source material really just puts it perfectly. That sand layer isn't just a little better at draining water. It is somewhere between 1,000 and 100,000 times more permeable than the clay sitting right below it. That's not a small improvement. That is a complete, fundamental change in how the material behaves.
100,000 times. Just let that number sink in for a second. It's the difference between water flowing through a sponge versus trying to force that same water through a solid brick. This right here, this is our aha moment. It's an absolute game changer.
So let's circle all the way back to our original question. Can that tiny 40-millimeter layer of sand really get the job done? Well, based on this data, the answer is a huge, resounding yes. This is no myth. It's a critical piece of incredibly smart, efficient engineering.
Okay, so we've proven it works, but now let's dig into why this tiny layer is so incredibly important in the real world. What is it actually doing down there under all that pavement?
Well, engineers have this awesome name for it. They call it a drainage blanket. And honestly, that's the perfect way to describe it. Because its number one job is to protect that much more vulnerable clay layer, which is providing all the structural support for the road. So here's how it all plays out in practice. Rainwater finds its way through tiny cracks in the pavement. Without that sand layer, it would just pool on top of the clay and sit there, turning the foundation into a soft, weak mush, which is the perfect recipe for potholes and cracks. But with our drainage blanket in place, the water hits that sand and is immediately collected and whisked away sideways. The clay subgrade is totally shielded, so it stays dry and strong, and that keeps the entire road above it stable.
Now, of course, this whole system isn't magic. There are a couple of critical real-world conditions. First, the sand has to be clean. If it's packed with a bunch of fine dirt or silt, it's just going to clog up and stop working. And second, there has to be somewhere for that water to go. A drain, a pipe, something. Otherwise, all you've really built is a very efficient but very full underground bathtub.
So here it is, the final verdict, all laid out. When it comes to drainage quality, sand is good, clay is terrible. The permeability difference? a mind-blowing 100,000 times higher for the sand. And their jobs couldn't be more different. The sand is the specialist, the drainage layer. The clay is the workhorse, the structural support. They're a team, but they have very distinct and very important roles to play.
It just goes to show you how understanding one simple scientific property can completely change how we build our world. And it really makes you wonder, doesn't it? Now that we've uncovered the hidden power of permeability, what other invisible engineering principles are out there, quietly shaping the world right under our feet?